Yeah, MLFlow is the library. We just dump everything. But if you want to use specific functionalities, you can use these functionalities as well. You can see MLFlow SageMaker is also there. MLFlow Escalon. This is something that we use. Right, and different other things are there. MLFlow is directly used by Azure. Azure Cloud is following MLFlow only. So for example, if you talk about machine learning workstation, the studio that we have used, internally it uses MLFlow only. Okay, so we will also redo that. We'll try and use notebooks, and I'll show how MLFlow comes into the picture when I'm using Azure platform. These are all readily available built-in machine learning models. We can try and readily use that. The latest of the information is getting updated in your official documentation of MLFlow. This is from official documentation only, but some time back. So you might want to relook at if there are some additional model flavors or models are added here. Okay, and you can simply follow the documentation to try and develop your machine learning models. So localhost, these are the default settings, and these you can see for every ML run execution, you will get one single folder created. And within that, we will have different files and different subfolders. Depending on what kind of model we are developing, what kind of artifacts, metrics, right, what kind of data we are trying to capture using MLFlow, you'll have different content in the folder. Every run, you'll have a unique ID like this. Alphanumeric unique ID will be created. Right, you can see parameters, metrics, this is your artifacts. Then you have tags. If you have given any tags, you'll also be able to see the tags. Right, so all these things will get captured. If you're running with localhost with database, SQL Alchemy database in the backend, then you need to try and connect to your URL. That's your database to record your metastore information. The red color box you can see is basically defining our local store. Okay, so these are different architectural designs that we have. Anyways, this is something that we can.
Shall the basic question?
Yeah.
Yeah, you talked about those different models or the runs that we are maintaining a record of, or MLFlow is maintaining a record of, right? And after that, we select the best model and deploy it.
Yes.
What is the need of keeping a repository of all the other models which are not being used, or the not so best models?
See, application. When you say best model, how are you defining the best model? On what basis you are defining?
No, once we have defined the best model and we have deployed it.
So if you want to compare it with, again, after a few days, you might want to compare it again.
After a few days, what changes is, say, a new data has come in. So anyhow, the pipeline will be run again and everything will be done from start itself. Then another repository will be created and then another best model will be selected. So is it a standard practice to keep all the versioning? And
yes, it keeps everything. So let me show you. Let's say this is data 1. This is the first time we are developing the models. So I'll have parameter 1, value 1, parameter 2, value 10, parameter 3, value 5. This gives me metrics, metric 1, metric 2, metric 3, some values, performance. These are like your accuracy measures, right? So this is one model that I have selected as the best model when I'm working on data version 1. After a few days, data version 2 came, new data come. Now, when I followed this entire flow, I observed that the best model is model 5, parameter 2 was model 2, value 2, parameter 3 was value 1, metric 1, metric 2, metric 3. Now you can see the parameters have changed, the values have changed for this model with this model when the data changed. Now you might want to, or your management might want to ask you, hey, what was the metrics or what was the performance of this model when I used same values on this new data? Or what was the result on the data one version when I was using these parameters here? Comparison, right? You don't know how you might want to compare or your management want to compare. So if you have data, you will be able to do it. But if you don't have data, you'll not be able to do it. So if you want to do it, fine, do it. But at least that provision should be available, right?
Yeah, got it. Thanks.
Right. And see, practically, we may say that this model is giving us best results because of accuracy. Let's say 92% accuracy is there. And it has some parameter. Because of that parameter, we are getting 92%. But when I want to practically use it, apply that in real world, the scenario could be in such a way that the business cannot accept this value. Though machine learning model says value 10 is giving us good results, but practically speaking, the business may not accept value 10 because of various constraints. In such case, what will you do? You cannot choose this model as the best model and deploy it, right? Because practically it is not applied or acceptable. So in such cases, you might want to go for other models which are acceptable. Based on the business conditions, you might want to see what parameters are to be considered, and in those parameters, constraints, given those parameters, which model is giving us good results. Not always go with respect to the metrics-based decisions. Right? Application is different from your model performance. So practically speaking, we never know which one we will choose as the best model for deployment. So from that perspective, everything is captured. And it hardly takes any storage space. Why you want to ignore the possibilities of all these various I should say research-based choices that we can select, right? Those options are getting diminished if you're not selecting the data. So why you want to lose that opportunity? Right? So from that perspective, everything is getting stored.
Sharath, will when you speak about management here, so will they be deciding what parameters that data scientists they only care about results, right?
This is no. Data scientists will do that.
Yes.
Given the set of parameters, which one is better?
Okay, but you mentioned that there might be a scenario where management might not can object using those parameters, right? So
yeah, obviously. So as a data scientist, you will know that, right? When you discuss with your management, you will know that, hey, these are the set of parameters I cannot apply because practically speaking, those are not allowed. So you are going to define the parameters in such a way that those parameters are not there in the first place. You will have the control, right, as a developer.
okay.
See, when we say model management, it's basically internally capturing the details. And that will allow you to manually evaluate which model you want to choose, which model you not want to choose, which is better, which is not better, how much time did it take to run with one experiment, what experiment parameters we have passed, what was the result on that parameters. All that data is available so that you will be able to do better management. Okay, that's all. It's not like automatically it is doing everything for us and we are getting the single result. No, to that extent, it is not automated. All right, coming back to the discussion, these are different things which got updated into MLFlow. There are different features. MLFlow 1.11, what was added, 1.12, what was added, 1.13, what was added, right? So these are all the different things that we have. You can probably go through all this and then try to understand the updates, right? It's not really hard-coded. The documentation should be available. You don't have to buy heart all this. As and how the product is getting mature, new features are getting added. Right? So you can probably follow through the change document and then understand how MLFlow has actually been upgraded.